While excavating at the La Brea tar pits, it seems like it's difficult not to find fossils.
We've got adult dire wolves, I've got adult coyotes, baby coyotes, turkeys, bison, baby horses.
The area is so rich that the excavators actually collect the flecks of dirt around the fossils and store it in buckets for further examination.
All of these still have to get gone through, grain by grain, to look for those little tiny fossils, those lizard scales, mouse toes, insect legs.
And this wall of buckets represents only a portion of one box,
This is an example of some of the other boxes that we haven't even opened up yet.
of which there are 23. The sheer enormity of fossil deposits at La Brea isn't just because it's a massive death trap. It's a testament to the preservative power of the tar pits.
Unlike a lot of classic fossils that are basically chemically turned into rocks, ours are, to almost all intents and purposes, still the original bone material. Because what has happened is that asphalt has seeped into all the little tiny spaces inside the bone.
Asphalt, not tar, is the black stuff bubbling up out of the ground. Tar is man-made. And if we're getting technical, not only was there no tar in the tar pits, they weren't actually pits.
So what we have that the animals are getting stuck in is really more a couple of inches of liquid asphalt staying at the surface that works kind of like a sticky flypaper, and you get stuck and you die of wonderful things like exposure, dehydration, predation if you're lucky. But again, that type of event, with one big herbivore maybe getting stuck and bringing in a lot of carnivores, and then all of the insects and birds and everybody else getting onto that type of event only has to happen once every decade to account for the millions of fossils that we have here.
And with around 60,000 years of Ice Age accidents to clean up, it could take a lifetime to excavate what's already been found. But with millions of specimens already in the collection at the nearby Page Museum, it begs the question, why do they keep digging? What could they possibly get from another 100 direwolf skulls or 1,200 Smilodon sabers that they haven't already got? Well, if you ask the Page Museum's chief curator, Dr. John Harris, he's the guy past the endless rows of fossils, there's many reasons to keep digging.
Because we've got so many species, we're able to put together a very complete picture of what life was like in the past.
A picture that can show changes within an unusually detailed time frame.
In most instances, if you could got something down to 60,000 years, you think you're doing very well. Here we're trying to get on a finer scale so that we can detect change through time.
For example, the lifespan of a single animal.
We've got something like 2,000 individuals of saber-toothed cats represented in the collections here, and they span all stages of the life, from very young to fully adult and elderly one.
And while you take a moment to mourn these saber-toothed kittens, the range of the tooth sizes in the museum's collection tells researchers how quickly they developed their killing canines, which in turn provides clues as to their lifestyle and social structure.
And then, because the individual tar pits are restricted in age, they are only active for a limited amount of time, we can then trace how species change through time.
Like the direwolves.
They're kind of like grey wolves on steroids.
Scanning and analyzing the Page Museum's massive collection of direwolf skulls, visiting researcher Dr. Robin O'Keefe determined that,
unlike the saber-toothed cats, which get larger, the direwolves actually get smaller through time. Normally, when you get a reduction in size, it means that the species is under stress, that it has fewer resources.
Insights like these may eventually explain why direwolves went extinct, and simply would not be possible without an enormous amount of skulls. While this explains why the museum keeps row upon row of megafauna, what about those buckets of microfossils?
We think that when we've been able to study the smaller fossils from the more recent deposits, we will see how the animals and plants of this region were affected as the area warmed up after the last ice age.
And understanding how plants and insects changed due to rapid global warming is, well, a pretty relevant and perhaps pressing subject to get our heads around. And so the digging and cleaning continues, adding to the mountain of data and giving us insights by the bucketful. For Science Friday, I'm Luke Groskin.